Let's practice what we have learned to solve a released problem from a Parcc examination. It is two parts which we'll address one at a time. The London Eye, a Ferris wheel in England, has a diameter of 120 meters. The wheel completes a full rotation in 30 minutes at a speed which allows passengers to enter a capsule at the base of the Ferris wheel without stopping the wheel. At the highest point, a capsule reaches a height of 135 meters above the ground. The height above the ground in meters of a capsule x minutes after it starts at the base of the Ferris wheel can be modeled by f of x equals a times cosine of pi x over 15 plus b, where a and b are constants. Part A. What values of a and b define the model? Enter your answers in the boxes. Part B. Consider a capsule that begins its rotation at the base of the London Eye. At which of the times listed will the capsule be 45 meters above the ground? Select all that apply. Here we have the problem written again, and our question is what value of A defines the model? The diameter of rotation is 120 meters, so the radius is 60 meters. The period is 30 minutes, so capital T equals 30 minutes. The maximum height is 135 meters, so we set y max to 135 meters. The minimum height is 135 minus 120 meters, which is 15 meters. The amplitude is 135 minus 15 divided by 2. So that's 120 divided by 2, which is 60. The midline is going to be 135 plus 15 divided by 2, so that is 75. The minimum value is at the start, so the function will be f of x equals negative cosine x. Let's use the key facts to write the equation so we can answer the questions. Alright, so we know the period's 30 minutes, we know the amplitude is 60 meters, we know the midline is 75 meters. And because the minimum value is at the start, the function will be a negative cosine wave. So we have our equation here, we plug in all of our information, and we see that A is equal to negative 60 and B equals 75. Now we can use the equation to solve part B. So we want to know at which times the capsule will be 45 meters above the ground. We are solving for when f of x equals 45 meters. So let's substitute that in and solve for x. So here we have f of x equals the equation, set f of x equal to 45, solve for x, and we see that one answer is 5 minutes. But this will also be true 5 minutes above the ground when it is coming down. So that would be at 25 minutes, and for all successive times derived by adding 30 to each of these. So it'll be at a height of 45 meters 5 minutes after it starts, but also 5 minutes before reaching the base on the other side, which is after 25 minutes. It will pass through 45 meters every period, so other answers are found by adding 30 minutes to either of these two answers. So you add 30 to 5 or you add 30 to 25. So here's a list of possible answers. 5 minutes, 25 minutes, we've added 30 to 5, we got 35. We've added 30 to 25, we get 55 minutes. Here we have 65 minutes, 85 minutes, etc. So here are our answers, B, C, E, and F. Using your knowledge of period, amplitude, and points on a midline, graph this function. Find the period by noting that the argument of the sine function is 2 pi x over t, and that must be equal to the given pi x over 2. So if you set those equal to each other, solve for t, we get the period is 4. The amplitude is the coefficient of the trig function. So in this case, that's 1, since there's no constant in front of sine. The offset of the midline is 3, so our midline will be at positive 3. And we have amplitude equals 1, period equals 4, offset equals 3. Let's plot a few points and then draw the curve. First, let's find the y-intercept. To do so, we just let x equal 0, and we solve, and we see that f of x equals 3. So that gives us this point right here. Now, let's let x equal 1. When we plug 1 in here, we end up with a value of 4. So that gives us this point right there. When x equals 2, then f of x equals 3. So we go back down to this point. Now, x equals 3, and f of x equals 2. So we draw this point in right there. When x equals 4, we get f of x equal to 3. So we bounce back up to the midline. Now, let's sketch the graph using those points and our knowledge that the amplitude is 1, the period is 4, and the offset is 3. So our midline is up here at 3, we have an amplitude of 1, and it repeats itself after 4.